Previously, we talked about how to graph an equation. Given an algebraic equation, for example, y equals 3x plus 2, we were able to graph it to get the straight line to show all the solutions of this equation. And we know when an equation has two variables, we will have infinite many solutions, as we see in the table here. So every pair of x and y will give us a point in the plane. And because, as you can see, we can pick infinitely many numbers for x, and we will get plug them into the equation, and we will get infinite many y's to correspond to each x. And each pair gives us a point. So infinitely many pairs will give us infinitely many points. And these infinitely many points joined together become a straight line. But today we're going to do it backwards. What if we are given a straight line? And how do we find the algebraic equation? So this is sort of like the beginning of mathematical modeling. We have a line or any other object, and we want to give a algebraic equation, and we want to use the equation to model it. And so, for example, let's say we have first. Let's draw our coordinate system. Say we have y-axis and x-axis, and we're going to say we have a line somewhere, and well, a line, we can move as you can see, a line even if with the same steepness, we can move it to get different lines. And so what kind of information will determine a line? So there are different information that given can determine a line. The first type of question we may have is, so let's see, when we have a line and we can see how steep it is, but the steepness, again, we're not determining the line, because when I move the line from here to here, it has the same steepness, but it's a different line. But if we add another piece of information, say, let's put a point somewhere, and then we say there's a point the line must go through. For example, say we have a point right here, and then we have we want the line to have a certain steepness, and then the line will be fixed, so that we cannot move the line anymore, because with the fixed steepness and with the fixed point, the line, if the line has to go through this point, we cannot shift it left or right. So we will get a straight line like this. So the first type of question, we're given slope, and we can use m to denote the slope, and given a point, and we're going to use x0, y0 to represent this point. And notice x0 and y0, that these are given. Again, these the slope is given, which means, say, m is like 2 or 2/3, something like that, and a number, the point, it could be 1, 2, or 3, -7, something like that. So these are numbers we will be given. The question is, how do we find the equation? Sort of like y equals 3x plus 2 or something else. And so the equation we're looking for must contain a variable x and y. And as we can see on the in this line, there are infinite many points. So this is just one of the points, x0, y0. But it has infinite many points in the line. So if you want to find the equation, of course, you will have to have two variables. Each point will become a pair of solution. So the idea is to do this type of question. The idea is we're going to say, okay, we have maybe a point here. We're going to look for this point. We call it xy. And notice the difference is I don't have any subscript because this point is different from that point. And this point could be the same as that point if this x quantity is the same as x0 and y is the same as y0, and then they will be equal. But for most of the other cases, and x0, y and y0 are different because this point can be moved anywhere. We can move it here, here, or there. So we can see, for example, so this x and y represent an arbitrary point in the line. So it could be anywhere in the line. So the next question is we want to set up an equation to represent this pair of solution. So the idea is because we're given the slope and we're going to use the slope formula. So if you remember, so let's write down the solution. The slope is equal to the rise over run, or you can say the change of y over change of x. And when we look at the change of y, so there are two y values. One of them is y, the other is y0. So if you want to find the change, we do subtraction. So we're going to get y minus y0 divided by change of x. And so we have two x values, and we do x minus x0. Make sure when you apply the formula, you should need to be consistent. If you start with this black point first, you will have to with the y, and then you have to use the corresponding x first. So you do y minus y0, you must do x minus x0. You cannot have them backwards for the bottom. So for example, if you do y minus y0 but x0 minus xy, x0 minus x, that will not be correct. All right, so this is the formula, and then we can to get rid of fractions. Usually this will be the answer already, because this is an equation that has x and y in there. And notice that m, x0, y0, they are all given numbers. And but we like to get rid of the fraction, so we're going to multiply both sides by x minus x0. So we're going to get m times x minus x0. Let me show you the work here. So this is what we did. We multiply x times x minus x0 on the left. We also multiply the same thing on the right, and this will cancel that on the bottom because it's multiplication. And the left hand side we just have m times x minus x0. I switched them, and then on the right side, because they are cancelled, we're just left with y minus y0. And again, normally we like to put y's on the left, x on the right, so we can switch the left hand side and right hand side. And this is the equation we're looking for. And this is actually the first formula. It's called point slope form. Apparently, the reason we call it point slope form is because m is the slope, and x0 and y0 is a given point. So that's why we call it point slope form. And later we will have other forms. So now let's look at a particular example how to use this formula to do a question. Say we have we want to find a line, find the equation of the line through this point, -2, 3, and with the slope equal to -4. So just like the information we have in the previous problem. So the slope m is given, and the point is also given, as we discussed before, if we have a slope, which means how steep the line is fixed, and it also has to go through a point, then this line will be determined, will be a fixed line. So now since we talked about this formula, all we have to do is to plug the numbers into the formula. So in this case, the slope m is equal to -4, and x0 is the x-coordinate of the given point, -2, and y0 is the y-coordinate of the given point, 3. So now we just need to plug all these numbers into the equation. Y, by the way, but when you plug in, make sure you plug these numbers for x0 and y0, not x and y. X and y, they are the variables of the equation. So we keep x and y. So y minus y0 is 3. So we replace this y0 with a 3. And then equals m. M is -4, the slope, and times x minus x0. X0 is -2. So there's another minus sign. This first minus comes from the formula. The second minus comes from the number x0. And if you want to simplify it a little bit, we can do keep change change to keep change change to get x plus 2. So it will look a little easier without two pairs of parentheses. So we get y minus 3 on the left equals -4 times x plus 2. So that is the equation. But it looks a little different from the equation we had before, say y equals 3x plus 2. And this form has a name. It's called slope-intercept form. We will discuss this in the next video. But the form we have right now is called a point slope form, just like what we have in this formula. So the reason is the number in front of the parentheses. This number right here is our slope. And -2, we changed the negative to a positive. -2 and +3 is our point. So we call this form point slope form. If they did not ask you to write your solution in a specific form, you can stop right here. So this is a correct answer. But if they ask you to write the equation in other forms, for example, slope-intercept form, you can continue to simplify it. So let's do a little bit of algebra work here. And again, the next part will be discussed in the next video. So for example, if you want to continue to distribute a number to get rid of parentheses, so we're going to have y minus 3 on the left, -4 times x, and then -4 times +2, that's -8. And we can also add a 3 to both sides to get y by itself. Y equals -4x plus 5. So this looks more like the equation we had before. In the first example, y equals 3x plus 2. So with y by itself on the left, something times x plus something. So if you want to do it, you can simplify that to this. And again, we have a name for this. It's called a slope-intercept form, which will be discussed in the next video. So both solutions are acceptable. They are just different formats of this equation.